Now I would like to call Ms. Evangelia MITSIAKOU as our next presenter. She is going to present us heat decarbonization of public sector housing, deep retrofit using an EnerPHit-Informed retrofit plan methodology. Ms. MITSIAKOU is a Passivhaus designer since 2015 with expertise in building energy performance, modeling, and low-zero carbon design. She has played a key role as a sustainability expert on numerous high-profile projects that target BREEAM Excellent or LEED Gold rating. As a technical lead, Evangelia also contributes to net zero carbon studies assessing retrofit strategies for large building portfolios.
I would like to thank you, ASHRAE Hellenic chapter, for accepting my submission for this presentation. And today's presentation is all about an approach to heat decarbonization in social housing, public sector buildings, through phased deep retrofit plan methodology that prioritizes energy efficiency. This way is how we think the main grid can become resilient to the climate crisis as we move towards electrification. So I'm Evangelia MITSIAKOU, working as Principal Sustainability Consultant for EICOM in the UK, and recently joined the office here in Greece, in Athens. I'm Passivhaus designer, EnerPHit designer since 2015. And I have been working as a technical lead for net zero carbon studies, both for various developers, real estate companies, or councils, assessing retrofit strategies for large building portfolio, both for domestic and non-domestic sector. So, as an introduction, I would like to set the context for this presentation. UK has strong policy drivers around decarbonization, which are similar to EU countries. Whether these are governmental, they come either from council policies or cross-disciplinary initiatives like LETI or recently published net zero carbon building standard. But decarbonization is not all about buildings, it can be infrastructure as well. For example, the UK Climate Act is a translation of the Paris Agreement in the UK, which asks for 100% reduction in national carbon reductions by 2050, against the 1990 baseline. So, narrowing down this policy to existing building stocks transition toward a net zero carbon future, the first step is to explore all technically feasible, ecological and economically viable methods to retain and retrofit the existing building stock. So this is vital for minimizing what we call embodied carbon, which are the carbon emissions during the building construction, and reducing the overall life cycle carbon footprint. But to evaluate the most effective retrofit strategies, we need a comprehensive feasibility study. We need a plan. This ensures that decision makers have a clear understanding of how to upgrade building portfolios and deliver high performance and low carbon buildings. But to define this retrofit plan, several critical factors, I think, related to low carbon heating systems must be considered, and the most important one is around the electricity grid. But this is outside the designer's control. So what I think are the key considerations is the carbon intensity of the current electricity grid capacity's limitations, influenced mainly by the location of the building, whether it is rural or urban, whether there are district heating systems available in the area, high distribution losses in existing older heat networks, technical constraints on replacing current existing heating systems with more efficient ones. Another factor is the recent upgrades to heating systems that may render further replacements financially or technically unfeasible, and the energy efficiency as a pillar for any decarbonization strategy. But why do we care about the grid? Lloyd Alter suggests that if we are going to have a chance of electrifying everything and running on renewables, we have to reduce demand and save the peaks. So we need to go a further step beyond renovation. And that's what I introduced to this conference today, is about the deep retrofit with a plan. So a planned retrofit compared to a typical renovation is an integrated approach to a building upgrade that focuses on improving the energy performance of existing buildings. This is a critical step in reducing overall energy use and carbon emissions, because we see the building as a system and we don't retrofit component by component. And why this is important? Because when looking at the building as a system and we suggest the retrofit strategies, we can see all the interrelations of the retrofit works. And that's what is important, because we may do a retrofit measure that probably will have a counter effect to the overall building. So we have here all the elements, all the components of a building, but what I want to highlight is how we see all these components for a building as a system. So when we have a plan, we may say that the first step we do is that we replace the windows because we have a funding, because the windows are single glazed, for whatever reason, and we do the easy retrofit work in most cases, which is to insulate the roof. After a couple of years, we do have a plan and we see, okay, let's introduce some insulation to the external walls, let's do the perimeter wall-to-floor insulation, perimeter to wall-to-floor area. Let's do some upgrade to the heating system, hot water, etc. And then, we see the ventilation strategy or introducing some renewables. When we have that plan, as I said before, we can predict the interrelations. So what if I change the heating system in 10 years' time? What do I need to do now? Or what if I add insulation to the external wall in 5 years' time? But also, it's not just energy demand, it's also about primary energy. And this is the EnerPHit-Informed Retrofit plan. So EnerPHit is a methodology, is a standard that looks into this more holistically and has a primary energy as well. So, why we want to have a deep retrofit rather than shallow retrofitting? All retrofits come to a step-by-step, or mainly that's the approach. What we want to avoid is the locked-in effect, which is if you do a shallow retrofit, you lose that potential of achieving the higher reductions in carbon emissions in 50 years' time. Because when you do a retrofit now, it's highly unlikely that you go back and add extra insulation. You will leave it there. So that's it. And that's the example I had for the project that I'm going to talk about. When I said to the client, okay, let's add some cavity wall insulation, but we don't have the budget for external wall insulation. Yeah, but will we go back in 25 years' time to add that? No. So what I want to, and the Passivhaus Institute wants to stress, to highlight this is, if you have a plan and the target of, for example, as we have it in this project, the 50 kilowatt hours per square meter energy demand, space heating energy demand, you can future-proof your building for the 2050 target. So these are the case studies, 10 buildings, or to state it better, 10 group of buildings, 10 sites. As you can see, they are both low, medium, high-rise buildings, but most likely they were built, most of them were built around 70s, so they were uninsulated. They didn't have any roof or floor insulation, but they had double glazing, poor performing double glazing. Only one had single glazing, and only one had roof insulation. I highlight this because you will see some results afterwards. So this is a matrix. We run 9 scenarios. So the first one is scenario A, just replacing gas boilers with more sufficient ones. Scenario B, a hybrid solution. So gas boilers with air source heat pumps, actually air source heat pumps with backup gas boilers, and air source heat pump only scenario. And that was the building services scenario. And then we had the retrofit works, the fabric retrofit works. Bronze was just the building services replacement. Gold was the target. And that's where I would say that I convinced the client to set a specific target than leaving that flu. So we have to hit the 50 kilowatt hours per square meter, and that helped a lot the design team to have a clear goal on what they were designing. And the silver scenario, which was in a way the first step of our retrofit plan, was to tackle the fuel poverty. So what we can afford, or what measures do we need to have some air source heat pump with a gas boiler, and at the same time keep the bills at the same level as before. That was the criterion for the silver scenario. So what I want to highlight here, okay, can you see my pointer? Yes. Okay. So you can see all scenarios for building 8 and building 10. What I want to stress is on the first one, the gas boiler only, just if you do the retrofit works, you can get the carbon emissions 3 times the savings as if you do nothing. Why we do have some carbon emissions the do nothing scenario, if you can imagine, is because of the grid decarbonization. It's over the 60 years period. So we are expecting that the grid will decarbonize at some level, okay? So that's why the do nothing has some savings. But if you see here, the air source heat pump scenario, we can go up to 5 times the savings just by replacing the heating system. So what I want to stress here is that I think that this is a misleading graph. Why is that? Because carbon is our metric. And we can't go just for carbon as a metric for any future scenarios. This is because we want some resilience for the grid. We can't just electrify everything and we expect that the grid will cope with that. We need to reduce energy as well. So that's why you can see at the moment, if we look just these figures, we may mislead our client or whoever is running this decarbonization into wrong retrofit works. For example, although I don't have it here, councils that just adding some renewables, photovoltaic panels in the roofs, and they claim that they decarbonize their portfolio, having the energy at the same level. So here another graph. What this shows is the capital cost needed carbon emission savings. That's the representation of the locked-in effect. Building 3 here needs more capital cost to have some meaningful carbon reductions. Why is that? Because it already had some roof insulation. So nobody will go and invest on that retrofit works. Whereas these ones, building 8 and building 10, were completely uninsulated. So it was more cost effective for the client to go and invest there because the carbon savings were greater. And okay, it depends on the size, etc. Probably we need a more in-depth discussion, but that's just to highlight this point of my presentation. This is a graph of all the buildings and how many savings we can achieve for the against the baseline for the heating demand. We can go down to 80%, and if we go for full EnerPHit, this can be 90–95%. And the load, we can go minus 60% savings on the load for each building. That's a great reduction. So, some lessons learned from this study. I will highlight a couple of these. Happy to discuss all the rest during the networking later on or the Q&A session. One critical takeaway is the need to steer the clients away from shallow retrofits and towards more comprehensive low-energy target approaches. Deep retrofit provides greater long-term value for significantly reducing energy consumption and carbon emissions compared to partial upgrades that may only offer short-term benefits. A well-planned, holistic approach ensures the full potential of energy savings is realized, avoiding the pitfalls of locked-in partial retrofits and might prevent future improvements. Another key lesson learned from this project is the importance of accurate and detailed data collection. We need this to establish a reliable baseline, which will be the foundation for all retrofit measures that we will propose later on. What we suggest as next steps is before finalizing the retrofit works, it is essential to explore various aspects of current and future building usage to ensure that any upgrades align with the actual needs and behavior of the occupants. In cases where actual data on occupancy and energy use are limited or not available at all, it is recommended to undertake further investigations in several key areas, like the use of actual hot water or electricity consumption data. This analysis can help identify any inefficiencies and inform decisions. Additionally, assessing the occupant comfort levels is vital, especially concerning overheating issues, where we saw that inside the flats they had 30, 34 degrees. In the UK, they said they felt comfortable. So gathering feedback from residents can provide insights into how well the existing heating system meets their needs and highlight areas for improvement. And finally, on one hand, this study highlights how deep retrofitting of housing can significantly contribute to the decarbonisation journey. By prioritizing energy efficiency in building retrofits, we not only support the UK decarbonisation goals, but also enhance energy security and grid stability. In summary, adopting energy consumption as a metric for reduction promotes a consistent, actionable, and adaptable approach to decarbonisation, ensuring that strategies remain effective and relevant across various regions and over time. Deep retrofits, on the other hand, offer long-term benefits such as improved occupant health and well-being through better indoor environments, reduced maintenance costs, and lower energy bills, helping to alleviate fuel poverty. Thank you.
Thank you very much. Do you have any questions?
Thank you, Evangelia. That was a great presentation. Of course, I'm working for a global insulation manufacturer, so you could imagine that such a presentation would appeal a lot to me, but I would like to hear your brief view on this aspect as a sustainability consultant mainly. When we're discussing sustainability and energy efficiency in buildings, we tend to focus a lot on the operational emissions, the emissions that are linked to the operations of the building, the HVAC, and we try to optimize those emissions. However, you already mentioned the term embodied carbon, and you already mentioned the positive impact that the decarbonisation of the grid and also of the upgrading and insulating of the building envelope will have in mitigating the impact of those operational reductions. So, after all, in fact, there are some data, or rather rumors, I would say, from some countries, let's say from the Nordics, Denmark, Sweden, where the embodied carbon, the emissions that are linked to the materials themselves and the construction, have becoming more and more important on the 50-year life cycle of the building as emissions. So the question, a simple question, I would like your very brief comment. Is the embodied carbon becoming the next big thing, if I could use the term, when we're discussing sustainability and energy efficiency in buildings?
You almost answered the question. Yes, it is, and from my experience, at the moment we are the moment of time where we try to convince the clients about retaining the building stock, which is the first part of keeping the embodied carbon low, and then introducing some materials. We are on the moment of time where we were with Passivhaus 5-10 years ago on how much will it cost if I use this material and not the other. And I think whoever understands that, and I would like to locate myself inside that, try to steer the client on thinking about embodied carbon as well. And I think there is a very good step in the UK, at least, for the releasing of the net zero building standard, where a lot of my colleagues took part, especially on the embodied carbon, where we try to push that as an industry. So these are the multidisciplinary initiatives that we took. So yeah, thanks for bringing that forward.
Thank you, Evangelia, for your presentation. And I'd like to applaud you for the concept of doing a deep retrofit on a holistic basis, because we've seen initiatives in Ireland in social housing where we've run into problems with mould and particulates because we haven't really done it in a full integrated way of the building. It's a sticking plaster approach. Have you done any follow-up with regards to indoor air quality and mould, VOCs and particulates in the buildings where you've done a deep retrofit?
They are at the moment of where they want to implement all these scenarios. So we don't have the results. But the ventilation strategy of the retrofit works was very crucial to whatever steps we were taking. So I'm really interested in what's the space exactly. I'm really interested to see that result. But this is what we highlighted, because in especially the high-rise buildings, they had centralized mechanical ventilation. And when we went there on site, the facility manager realized that it didn't work. Anyway, but we saw all these molds, especially at the top floor, where it's supposed to be windy, because the occupants didn't open the windows because of the high winds. So, I mean, that's why I stress the fact that we want occupants' behavior as well as occupants' feedback on how they operate the building. You can't just go there and say, okay, let's insulate everything. I mean, it's, yeah.
Thank you very much.
Thanks.
We would like